Welcome, everyone, to episode 3 of Get It Right in Black and White. Um, I've been really looking forward to this one because it's where we're going to dive into DOM manipulation with JavaScript. All right, so here's what we're going to talk about this time. Sol LeWitt reproductions in vanilla JavaScript. And this thing right here on the screen is a Sol LeWitt piece. What we'll cover today, first I would like to review the exercise submissions from last week. Got some really good ones. And then I'll talk about Sol LeWitt, this artist who's done a lot of really amazing pieces that we can reproduce with JavaScript and SVG. Then I'll talk about JavaScript basics, like JavaScript language features. And then I'll talk about the DOM API. So we're not going to use any libraries, no D3. It's just going to be vanilla JavaScript, DOM manipulation. And to implement some of these Sol LeWitt pieces, we're going to need to use SVG masks and perhaps SVG clip path. All right, so let's review these exercises. So here's the forum post from last week's assignment, which was recreate a pseudo visualization from a visualization taxonomy. I'm just going to step through these works. Here's one from Nita, a pseudo Venn diagram. Very nice. Oh, Nita's here. Do you want to talk about this at all?
Yeah, I can talk about it. I made this one using Figma, just basic three circles, and from the link that Karan shared last time, basic Venn diagram. It took like not that long to make it, and just exported it using SVG. So each shape here is SVG, and yeah, that's it. Thank you.
Very nice. Very nice. Here's a pseudo Gantt chart from Philippe Maillon. Forgive me if I'm not saying that correctly. But this is very nice. Very beautiful. I mean, this is getting into some serious data viz type stuff with the numbers and the labels and the grid, and there's a dashed line. This is fairly impressive. This is amazing. And to be able to implement this later with D3 would be a great direction for a project. Wasim made a pseudo slope graph. Very nice. Very nice. I appreciate the styling with the font and everything. It's very much in the theme of Get It Right in Black and White. And this is one of those visualization types that we can definitely implement in the future with real data with D3. Andre made a pseudo spider chart. This is pretty neat. Also sometimes called a radar chart, where, yeah, it could visualize different dimensions of the data along this circular grid shape here. Very nice. And here's a pseudo icon array. This is pretty cool. Pretty cool indeed. And I love the creative font and the trees here. They're sort of filled in at different levels. Very nice work by Senna. And Adil, check out this one by Adil. Oh my gosh. This one, when I saw it, I was so happy. This is just so gorgeous. So gorgeous. Adil, you want to talk about this one a little bit?
Yeah, this was a really nice exercise. It's circle packing is plays on the tree structure, and each circle represents a level and also a branch. So, in the case of subcircles, will also represent subbranches, and um, and it just I think it brings out the hierarchy at different levels of the tree quite nicely. And I think maybe one improvement I could have maybe do in the future is to probably apply different shadings to the different levels, circles, just to bring that maybe bring that emphasis of the hierarchy out a little bit more. But yeah, this was a really nice, fun exercise, and built in. The shapes were built in Figma, and the text was added later inside VisHub.
Oh, very nice. That's a great approach. And I have to say, I love how the consecutive levels are inverted. That's a really nice touch. Really nice. And I love how it's just totally black and white. But yes, if you were to add color, you could do a lot of different things with this type of viz. And this is another one that we will definitely implement later with D3 based on data. So I love where this is going. There was some discussion about how is this animation done. It was using Three.js, which is this really crazy three-dimensional library that we might touch later on. But yeah, the point here is that if you inspect the DOM, you can do some sleuthing and figure out how these various things that you find on the web were done. Alenka did this really nice pseudo joy plot. Very cool, very cool. And here's another one from Kirsten. This faux data viz. It's a approximation of a stream graph. Very nice, very nice indeed. Yeah, this is another one that we can implement in the future with real data. So great work from everyone on these. All right, now I'd like to talk about Sol LeWitt. The whole context for this is that I went to this exhibition of Sol LeWitt art years and years ago, and I was very inspired by the art. And years later, I was thinking, oh my gosh, this is perfect stuff to recreate with code, because it highlights some of the sort of foundational things that you can do with code. This is Sol LeWitt. He was an American artist, and he's done all sorts of interesting art pieces. He had a very sort of storied career in art, and he does these large-scale exhibitions in large spaces. Here's a piece by Sol LeWitt where it's this giant set of shapes installed on a wall. And as you can see, it's like bands of black and white, vertical and horizontal, with different masking patterns applied. So this is one of the pieces that I think is really nice, and this is the one that I would like to try to reproduce today by writing code. And I really look forward to it. It's going to be a lot of fun. It may be too ambitious to have the multiple shapes done today, but I was thinking just the first one, the leftmost one here with the circle masking pattern. I think that's what we can target for today. Before we dive in, though, I would just like to take a look at a couple other Sol LeWitt pieces. Here's another variation on that theme of different textures going in different directions. Here's another variation of the same theme with sort of larger scale textures and adding color to some of them. Here's another piece that explores colors with patterns. I don't know how to describe it really, but some of the same themes are present in this one. Here's another piece by Sol LeWitt where it's interconnected lines between randomly placed points. And by the way, the general theme with Sol LeWitt is he would not do the art himself, I don't believe. Or there's probably changed in different places in his career, but the main thing with Sol LeWitt is he would give instructions, almost like algorithmic instructions, to a crew of people that would implement his artwork based on those instructions. So it's very algorithmic to begin with, and it's ripe for implementing with computer code. Here's another Sol LeWitt piece. that is just a grid that's expanding. Very fundamental. I love it. Let's dive in to trying to reproduce this Sol LeWitt piece with code. I'm going to start by creating a viz. I'm going to fork from this SVG fundamentals viz that we did earlier. I'll fork this and call it Sol LeWitt reproduction. All right, we've got this sort of blank canvas here. I'm going to just adjust the README and say a reproduction of a Sol LeWitt art piece, and I would like to link into it. And this is a good opportunity, actually, to talk about how to make links in Markdown. A very small sidetrack thing here. This is how you make links in Markdown. It's very useful. So whenever you add a description to things in your vizzes, it's always a good idea to link to whatever resources you're drawing from. And the way to do that is with square brackets for the text. See, that becomes a link there. And then in parentheses, you put the URL where the link is going to go. And here is the actual article that I got that image from. So I'm going to paste that URL right there. That's how you can add links in Markdown. And then in index.html, I'm going to clear out all of this stuff in the SVG. Okay, from here, what I would like to do is start using JavaScript. And the way that we can start using JavaScript is by introducing a script tag inside the HTML page. So script, not script, like that. And what this does here is it opens up a whole world of JavaScript. You can put stuff in this script tag that is, statements in the JavaScript language. And so the most basic JavaScript program is called Hello World, and it looks like this. Console.log hello world in quotes. And then if you open up the Chrome DevTools, by clicking on this little icon here and then going into More Tools, Developer Tools. By the way, this is like something that you have to use pretty much all the time when you're developing JavaScript. So I would recommend learning this keyboard shortcut, Control-Shift-I. So inside the Developer Tools, we've got different tabs. We've seen the Elements tab when we inspect elements, but then there's the console, meaning the JavaScript console. And by the way, with Chrome DevTools, you can use this little widget here to move the DevTools around. I believe by default they may be on the right. So, but I personally prefer to put them on the bottom. And within here you can change the font size with Control plus and Control minus. But anyway, when this program runs, it outputs Hello World right here. There are a bunch of things going on here. Console is a variable that's just there in the browser. And when you say console.log, you're accessing a property in that object called log, and it happens to be a function. And that function gets invoked with these parentheses. And then the argument that is passed into that function is this string. It's called a string when you put something in quotes. That is hello world. At this point, I want to just stop and take a brief tour of the JavaScript language. It's not going to be in depth, but it's just for folks who've never seen JavaScript before. This course is for such people. You don't have to know JavaScript already, and I want to introduce everything that you need along the way. So that's why I'm going to just touch upon some JavaScript basics. So inside of console.log, you could put any JavaScript expression for example, numbers. If I hit console.log 5, it prints out 5. And in JavaScript, you can comment things out with two slashes in the beginning of the line. I'm going to comment out everything that we cover so that this thing is here as a record of what we've done. Console.log 5 works. It just outputs a number. This highlights that you can pass different types of things into console.log. It accepts strings, it accepts numbers. With numbers in JavaScript, you can use arithmetic, like 5 plus 5 is 10. That works. And there are various operators. 5 times 5 works as well. That gives us 25. Parentheses work the way that you would expect them to with math. So if it's like 2 plus 3 times 5, that's one thing. But then if you put parentheses around a group, that's another thing. So these are basic arithmetic operations in JavaScript. There's also a fundamental concept of a variable in JavaScript. And for that, in modern times at least, we use let or const. So I'm going to say const num equals 5. That creates a variable that's called number, and it sets the value of that variable to 5. And then we can say console.log num, and that references that variable, and it outputs 5 here. The thing with const, though, is that you're not allowed to reassign to it. So if I say num equals 10 like this, it says, ooh, that's not allowed. And that's why it's called const, because it's a constant. It's not allowed to change over time. This breaks. In order for that not to break, we can use let. If we say let num equals 5, we console.log num, we get 5. But then we can say num equals. This is called reassignment of a variable. It's changing the value that it has over time. So if we say num equals 10, it changes the value of num, and that works because we're using let, not const, and we get num. And in some older code that you might see var. And var works just the same as let for the most part, but there's some differences about scoping, which we can maybe get into at another time. It's not really so critical. Older format behaves like let. And what else? In JavaScript, we have objects. Objects are critical. So if we want to create an example object, we could say const obj, or I'll call it object. And the way that you create an object is with a pair of curly braces. And then objects can have properties inside of them, like num, for example. And then the way you set the value of properties is with a colon, like this. And now we can say console.log object dot num. The dot is how you access properties within objects. So it prints out 5, and that works. And while we're here, I want to show you a thing that is a little conceptually tricky to grok, and that is you can assign properties of objects even if the object itself is stored in a const. For example, object.num, we can assign that to a new value, and it works. See, it says 10 here when we access it. And that's because we are mutating the object. We're not reassigning the variable object, that's called object here. We are just changing its value, its internals. This is called mutating something. So that's the essence of objects. Another piece that we'll need is iterating over loops, because when we do this texture thing, we're going to have to make a shape many, many times. And to do that, we can use what's called a for loop. And I'm going to type this up in a comment so that it doesn't break. Because if you run a for loop before you stop typing it, sometimes it gets into this infinite loop situation. And so this looks like this. For, we put some stuff in parentheses, and then we put some stuff in curly braces. In the parentheses, we can set a variable, let's say I, to 0 initially, and then say, as long as I is less than some number, like 5, we increment I plus plus. By the way, let me just introduce the plus plus operator on its own. So if we say let num is 5, console.log num, we get 5. We can say num plus plus. That increments the number by 1. So now we get 6. It's the same as num equals num plus 1. And so now it's incremented twice, so now it gets 7. So that's the plus plus operator, increment operator. And also there's another construct, this less than. There are comparators. So if we say like 4 is less than 5, that outputs true. And true and false, that's another primitive type. You can say true, console.log false. These are booleans. So if you say console.log 4 is less than 5, that says true. Yes, it is. But then if you console.log 4 is greater than 5, that outputs false. So those are these comparisons between numbers that you can do in JavaScript. And these are, to be clear, these are expressions in the JavaScript language that return a value that is a Boolean. And these can be nested with parentheses and whatnot. That's the beauty of programming languages. But anyway, now that we've got this for loop here, I'm going to uncomment it, and then inside of these curly braces, I can say console.log I, and it outputs these numbers 1, 2, 3, 0, 1, 2, 3, 4. See, it starts at 0. And that's the usefulness of a for loop. You can have one line that just does one thing, but the for loop says, okay, do that one thing, X number of times. And it gets repeated. I'm seeing there's a question in the YouTube chat. Can you assign without const? For example, just stating object.num equals 10 without first assigning the property with const. I can maybe clarify that. So it's about this example here. Maybe the question is, can you just say object.num equals 10 without defining object first? No, you can't. You have to have object. It has to be something. It has to exist first. However, it does not need to have the property inside of it. So I'm going to comment that out, make another copy. It does not need to have num defined first. So it could just be an empty object, and then you can create a property on that object that didn't exist before, just like this, and it works. Yes. So I hope that answers your question. I hope that answers your question. You don't need to have the property declared like when you create this object. It can be added after the fact. But the object itself needs to exist. If the object doesn't exist, you get this, what's called a reference error. It says like object is not defined, because it's not. There's nothing called object. So there you have it.
As we talked about objects, can we talk about other basics of JavaScript like functions?
Yes, while we're here, let's do it. I want to cover each and every fundamental concept, not in a deep level, but I do want to cover it. So let's say we want to add two numbers, 5 and 5. We can introduce a function to add two numbers. I think this is a good first example of a function. So I could say const add equals a function that returns a value, and this is ES6 syntax for defining functions. It can take as input two numbers. I'll call them A and B. and it can return A plus B. So now we can say console.log add 5 and 5, and it says 10. And so if we say add 5 and 10, we get 15. Now, this is how you would do it with ES6 JavaScript syntax. I want to talk about the different variants that you might see of this. So this is one way of defining add. Another way of defining add, you could say function add, and then put the parentheses right here, and then open it up into curly braces, and then say return a plus. This is the sort of old school way of defining functions. It's valid JavaScript still today, but as you can see, this arrow syntax is much more concise. Another way of defining add is like this. You could say const add equals a function that takes as input A and B, and then open up into curly braces. See, when you open up into curly braces, you can put many, many different lines of code in there, and those lines of code will run when that function gets invoked. However, you need to explicitly return the thing, like this. Return A plus B. See, now it says 15. And that's a little confusing thing about this syntax up here, is that it uses what's called an implicit return. It implicitly adds this return statement if you don't open up the function body with curly braces.
Karan?
Yeah.
I was just curious, what if we happen to be returning an object?
Oh, that works, yeah.
The curly braces, if we had multiple statements and then on the last line we are returning an object, would that be oh, I see. Yeah, I think so. Yeah, the curly braces for the first function would be just be the function body, and returning an object would still be okay. Yeah, that's fine. I think
I understand what you're getting at, and I would like to walk through that. So let's say, for example, I'll start with the old school syntax. Let's say we have a function that's going to return a person object with a first name and last name. If we were to construct that object, let's say I'll call it person example. This is going to be like the output that we would like. First name is Jane. Last name is Doe. It's a generic name. This is the kind of object that we would want to create from a function. And so then we could say person example dot first name, and it'll output Jane, and then console.log person example dot last name. It should output Jane and Doe. And by the way, you can console.log an object, which we do often, and then you get this little inspector for that object in the DevTools, which is super duper nice. Okay, this is setting the stage for writing a function that generates such objects. So I'll call it create person, and it can take as input first name and last name. Or for the sake of brevity, I'll just call it person, first and last. And what we can do in here is say return an object, and that object can have first being the property of the object. We can assign the property of the object called first to the value of the variable that's inside this function body called first. This is called a closure, by the way. The arguments become visible, just like variables, inside of this closure that's demarcated by curly braces. So we can return an object where first is first, last is last, and now we can say console.log person, and then we can pass in Jane and Doe, and then we should get this object back. This is first Jane, last Doe. So to get at your question, how does it play out with the ES6 arrow syntax? It is a sort of tricky business. And let me show you what that looks like. We can refactor or rearrange this code to use ES6 arrow functions. So const person equals a function that takes as input first and last arrow to curly braces, and then the inside of it can remain just the same like it was. This is one valid way to do it. And yeah, no issues, no confusion here. The place where it gets confusing is when you start to leverage the implicit return on those that arrow function syntax. So the way that looks is if you want to return an object, you can't just do it like this, as in first name, last name, like this, because it gets sort of confused about, is this an object or is this a opening up of a function body? So if you put a begin curly brace directly after the arrow, it's always interpreted as, okay, we're opening up the function body now. So this is not valid code. It says unexpected token. What you can do, though, is use parentheses to say, okay, I am going to return the thing that is inside these parentheses. So this version of the code works. And I think this is what you were getting at.
Yes, absolutely. Yes, it was the thinking about how ES6 syntax would accommodate returning an object. Yeah.
Yep. Nice. And this is it. This is how it works. As the last thing in this segment with this function, I want to highlight that in ES6, the most recent version of JavaScript, there is a simplification that you can do in the case that the property name matches the variable name. And that is, you can just get rid of this stuff here. And it automatically assigns the value of the property called first to the variable that's in scope here called first. So it's a shorthand for defining object properties where the property name happens to match the variable name. So this is sort of the most concise way of implementing this person function, and maybe it could all fit on one line. Yeah, it can all fit on one line, and that's like a very concise way of doing it. All right, that concludes our foray into JavaScript. I did not touch arrays yet. I think I'll do that later once we start using them, but this is a first pass at some stuff in JavaScript. Okay, since that's what this really is, I'm going to rename this to be JavaScript Basics. And then I'll fork this one into LeWitt Reproduction. Okay, now we can start having some fun. I'm going to delete all this stuff. I would like to build up the DOM for this textured background that we see in the LeWitt piece. Within this piece, I'm going to first target the background of one of these squares. So it's going to be the background of the leftmost square, where we're just going to have vertical lines going across the screen. That's the first target. Now, to do that, I think it makes a lot of sense to use JavaScript so that we can automate the creation of those rectangles. Otherwise, we would be, creating 100 rectangles by hand, which is just not practical. But to get there, we need to build up this SVG using JavaScript. As a first thing, I would like to create this particular SVG element using JavaScript. Now, how do we do that? Well, it turns out there's this thing called document. If we say console.log document, we can see what this is. It says document. It turns out it is the HTML document. It's a DOM node that you can unpack. See, it has the head, it has the body. All of this stuff is available to you in JavaScript. So what we can do is say document.body. That actually gives us the body element. And on the body element is where we can append things using JavaScript. So as a first goal of something to create using JavaScript, let's create this SVG element itself. The way we can create a DOM element, a DOM node, part of the document object model, I'm going to make a variable. I'll call it SVG. And we can use document dot create element, and we can give it SVG, which is the tag name for this element. And now if we say console.log SVG, we see that it is in fact an empty node that is SVG. Right now, though, this DOM node is sort of hanging in space. It's not actually attached to the DOM. It's just in memory in a variable. To put it on the page, we can use on the body, we can use a method called append child SVG. That will append this DOM node to the body. And if we inspect the elements on our page here, now we should be able to see that in fact there are two SVG elements now. See, there's the one that we created in our HTML syntax, and there's the new one that we created with JavaScript. My aim is to replace this first one with the second one so that we can add more stuff into it. It's going to need to have width and height. So how do you do that? Well, we can call svg.setAttribute, and the first argument is the name of the attribute, namely width, and I'll set that to 960. And from the JavaScript perspective, you can pass in numbers and it will be coerced to a string. So that's what I'll do because it's conceptually a number. And then svg.setAttribute height. svg.setAttribute height to be 500. Now, if we inspect the DOM, we can see that there are two identical SVGs. Look at that. So now I can delete this one that's defined in HTML and just have the one that's defined in JavaScript. There it is. So this is our starting point for JavaScript-driven SVG without any libraries, without using D3. D3, when we do start using it, is going to do all this stuff. D3 uses all of these APIs internally. It just gives a nice way of interacting with these APIs. All right, now that we've got this SVG element, let's create a rectangle that goes inside this SVG element. I'm going to do that by copying this block because it's structurally very similar to what we want to do. We want to create a new element, let's say a rectangle. We can say document.createElementRect to create a rectangle. Rectangles also have width and height. So I'll just set it to 100 and 100 just so we can see something. And then, instead of appending a child to the body, we can append it to the SVG. This is how you can programmatically build up a tree data structure, which the DOM is. It's a tree data structure. So svg.appendChildRect should add that rectangle to our SVG. And I noticed I have inconsistent formatting. I'm going to use prettier to just make everything consistent. We should be seeing a rectangle, but we're not. Let's see if the DOM is correct. Oh, it's not. The width and height is 100 on the SVG somehow.
You have to change attribute.
Yeah, I just forgot to update it here. So rect.setAttribute should be the one. Okay, now if we inspect it, we can see that it is there. All right, it is there. SVG has width and height. The rect is there, but it's not showing up. The reason why it's not showing up is because we're using create element. Create element does not work with SVG. You need to use create element NS. So here's why. SVG in HTML is a fantastic addition to the web platform, but since SVG is an XML-based language, see, it comes back to that concept of it is based on XML, there is some nuance in how it can be used. When parsing HTML, meaning if we write SVG and those attributes in HTML, SVG elements are automatically created correctly so long as they're inside an SVG block. But SVG elements cannot be dynamically created with create element in the same way as HTML elements. It's in order to dynamically create SVG elements, you must explicitly tell the browser that you want to use the SVG namespace. So this is something that's particular with XML. I must admit I don't fully understand it, but what I do understand is this is how you need to do it in order for it to work. So let's try this in our code. I'm just going to paste that block here for reference. It's .createElementNS passing this namespace string that I think what it's doing is saying, okay, this is an XML document that uses the SVG namespace, meaning it's an SVG XML document. So instead of document.createElement, we can say document.createElementNS. Pass that thing and say, okay, this is an SVG container element. And similarly with the rectangle, we can use the same thing. Okay, now it shows up. All right. So this is how we can create SVG elements that work using the DOM API. Now, let's get into creating a bunch of rectangles to approximate that sole LeWitt piece. This rectangle is 100 by 100, but what we're going to do is we're going to create a bunch of vertical lines with rectangles. So the width of them could be small, let's say 10, just 10 pixels, but the height of them should be the same as the height of the whole thing, meaning 500. See, now it's going to go all the way down the screen. And we can move this rectangle around by setting x. If I set x here to be 10, see, it moves over a little bit. If I set x to be 100, it moves over 100 pixels. Now at this point, I see some duplication, duplicated logic in the code. It's a very simple form of duplicated logic, but instinctually I think to myself, oh, there should not be duplication like that. And that is the 500 and 500. Now that we're out of HTML and in JavaScript, we can start using variables and later functions to eliminate duplicated logic, meaning if you have to define something multiple times in different places, it's preferable to just define it in one place so that you can, if you need to change it, you could just change it in one place. So to do that, I'm going to say const width equals 960 and height is 500. And then wherever there's 960 in use, I'm going to use width, and wherever there's 500 in use, I'm going to use height. So setting the height of the SVG and the height of all of these rectangles. So that's just a simple refactoring. And at this juncture, I want to point out that instead of hard coding these, we can actually read them from the parent page, which I always love to do because then when somebody loads the page and it's resized differently, it'll use whatever width and height the page actually is at the time. And the way to do that is, I believe, window.inner width and window.inner height. Yeah. So window is another thing, kind of like document, that's available in the browser that you can call upon. And using inner width and inner height gets you the actual dimensions of the page when it's loaded. Okay, this feels right to me. There's no numbers that are hard-coded. I find this beautiful. Oh, except for 110. But I feel like maybe those are fine for now. All right, now that we've got one rectangle, let's make many rectangles. And conceptually, what we want to do is, have this code run, but just change x every time. But rather than copy paste it a bunch of times, I'm going to put it inside of a for loop. For, and I'm going to type this in comments so that we don't run into an infinite loop situation. For let I equals 0, I is less than n. I like to use n so that we can change it later if we want to. Initially, I'll set it to 100. Let's make 100 of these. I++. And by the way, in VizHub, if you ever do run into an infinite loop, you can just type #recover at the end of the URL. And this is how you enter recovery mode. In recovery mode, you can edit the code and it's not going to automatically run. And then when you're done fixing the code that created the infinite loop, you can just hit exit recovery mode. But anyway, hopefully that'll never happen. So now, inside of this for loop, this is where I'm going to move this code. I'm going to cut this code with Control X and then paste it into this block with Control V, and then use Prettier to update the formatting so that it's all indented properly. And now we can use I to move things around. See, I starts at 0, and then the second time around, I is 1. And then the next time around, I is 2, and so on, until it gets to be 99, in which case, this still runs for the 99th time, but when I gets to be 100, this check fails, because 100 is not less than 100, and then the for loop exits. So our values of I are going to be from 0 to 99. So the thing that we want to vary is x. If we just set x to be I, it's going to go across the screen, but it's only going to move 1 pixel at a time. Right? So if we want it to move, let's say 20 pixels at a time, I can multiply I times 20, and we get it. There it is. There it is. I see there's a question in the YouTube chat. For properties on the window object, you actually don't have to write window.innerWidth. Just inner width should be enough for the browser to get it. Yes. Yes, that's true. That is true. Window is an alias for the global object. So you can actually say inner height and inner width just like that. And it works just the same. It's true. Yeah, thanks for that. Thanks for that. However, if you use a bundler or a build tool, something like that, it will complain and say inner width is not defined. So that's why I just sort of, by default, I do like to explicitly say window, because those tools, well, we're not using them now, so it doesn't matter. But if you are using a tool that sort of checks, or ESLint, for example, that checks the validity of the code, it often would complain that, okay, these variables are not defined anywhere, so That's an error. But those tools do understand that document and window are things that are provided by the browser and are expected to be in the global namespace. So yeah, that's why you may need to use window. And I see there's another comment. You do need window prefix for ESM. ESM. Oh, modules. ECMAScript modules. So, I don't know. I'll just, I think I'll keep it here for now, but I'll just add a little comment that says Windows optional sometimes. But yeah, it's a great little side discussion. Thanks for that. Any other questions in the meantime?
Yes, I think I have one question. I'm curious about the const inside of the loop. It looks like it's being reassigned, but it's not. And I'm curious as to how that works.
Yeah, that is a great question. It looks as though const is reassigned here, but in fact it's not. That's because const and let are block scoped, not closure scoped the way that var is. So what that means is the block that gets opened up with these curly braces and this for loop defines the scope of that rect variable. Let me give a concrete example here. If I say console.log rect, out here it says reference error, rect is not defined. And that's because we use const and it's block scoped. That means that that variable does not exist outside of that for loop. And so essentially every time that for loop runs with another version of I, that const is recreated in a brand new block scope. And so that's what makes it so that const, like this rect, it's never actually reassigned. The whole variable is recreated again and again each time the for loop runs through one of its loops. However, if we were to use var here, check this out, then this console.log rect actually succeeds. It actually prints out this DOM element here. Why is that? Well, it's because when you use var, it's actually scoped relative to the closure that you're in. So right now we're in the global closure because we're not inside of any function definition. But if we were inside of a function definition, the curly braces of that function would define the closure, meaning the scope of that variable. And this is actually the core difference between var and the new constructs of let and const. Let is also block scoped. So this is actually the difference, the fundamental difference between var and let. Var is closure scoped, but let, see if I use let here, it's block scoped, meaning it's scoped within the for loop. That's why we get this reference error when we try to access it here. So yeah, that's a rundown of scoping with var versus let and const. I'll switch it back to const because it's generally, I think, and this is a personal preference thing, it's generally good practice to use const, to default to using const until you have the need to reassign it, and then you can use let. It just makes it easier to read the code later on for your future self or for anybody else reading the code. Someone says let would still be nicer there, but I respectfully disagree. I mean, you could use let. I see actually a lot of developers use let by default, but I would argue strongly that it's best practice to use const, because when the reader of the code in the future sees that, it's clear, okay, this is not going to be reassigned. It makes it easier to reason about the code. When I see let, when I read somebody else's code, I immediately look for where it's going to be reassigned. I'm like, oh, that's like something confusing. I have to think about it. It could be reassigned to value. Where is that reassignment? And that's where I immediately would go. So that's why I would strongly argue that just use const by default. And if it turns out that you need to reassign it, then yeah, change it to let. Change it to let, but only if you need it. That's just my personal take on all this. All right, so I would like to actually reproduce that sol LeWitt piece. We've got this as one of the directions of the sol LeWitt piece. Now I would like to change it around so that the texture goes the other way. That way we have our two ingredients that we will eventually put together with this clipping path thing. To do that, I'm going to fork this viz, and I'm going to call it sol LeWitt reproduction vertical. It's just going to be a vertical variant. And how do we make it a vertical variant? It's just changing around this stuff here, this logic here. Instead of x varying with I, we can vary y with I. So y now can be I times 20, and instead of width being 10, height can be 10, and width can be the value of the width variable. Okay, that's it. Now we've got our vertical and our horizontal. And now what we can do is we can use an SVG mask. The idea with an SVG mask is it defines an alpha mask for compositing things. So what we can do is say mask, give it an ID, and this mask is going to be the circle in the sol LeWitt piece. See how this circle in the middle masks the textures? That's exactly what we're going to do here. So we're going to have a black background and a white circle for one of the textures, and then a white background and a black circle for the other of the textures to invert the mask. And this is how we can implement this piece. So it looks generally something like this. We create a mask element inside the SVG and give it an ID. Let's do that. And since we're in this world of JavaScript generated stuff, we need to use this API, which gets cumbersome pretty fast. So what I'm going to do is copy that block of the rect, and I'm going to change this to mask. Document.createElement and as mask. I'm going to set the ID attribute to something arbitrary. I'll just call it I'll call it circle mask, circle-mask. We don't need anything else. And then we say svg.append child mask. And that has to set the attribute on the mask, and we append the mask as a child. Okay, now that we've got that mask, we can create a circle within that mask. So I'm going to copy this block again, and I'm going to say circle is document.createElement and as circle. And then on that circle, we can set the attribute of cx and cy to be the middle. So cx would be width divided by 2 to put it in the middle. Cy would be similarly height divided by 2. And then we want to append the circle to the mask. It has to be a child of the mask. Now that we have this, we can set the mask of these rectangles to be that circle mask. And let me just consult the documentation again. So on any shape, you can say mask equals URL parentheses hash the ID of the mask. And it's kind of a quirky way of doing it, but you know, that's just what it takes to make it work. So I'm going to paste that reference, and then on these rectangles, we can implement that by saying rect.setAttribute mask, and the value of that attribute is going to be URL hash and then the ID of our mask, which is circle-mask. mask. And I think that should work. It did not work. Oh, because we need to set the fill of the circle, I believe. So let's set the fill attribute of the circle to be white. I think this is how these masks work. No? Black?
We don't have vertical rectangles at all.
Yeah, I know. We're not seeing them because I'm setting the mask. If I remove the mask, then we do see them. Question is, why is the mask not working? Oh, I believe I didn't set the radius of the circle. Ha! Silly me. So R of the circle can be, let's say 200. And we may need that fill after all. Okay, so we need CX, CY, and R. I'll just try a value of 200 for R. And let me try setting the fill to be white. Ah, there it is. There it is. Woohoo! Got there. So now the next challenge would be to invert this mask for the other texture. The way that we can invert the mask is by setting the fill of the circle to be black, and then we put a white background rectangle within the same mask. Because the way masks work is black becomes you can't see it, and white becomes you can see it. So I'll follow the same pattern as we have for the circle, but with the rect. I'll call it mask rect so that it doesn't conflict with the other rect. Maybe it wouldn't anyway, but anyway, I'll call it mask rect, and the tag name will be rect. And on the mask rect, we can set width and height, just to be width and height, because I want it to fill up the background. That's the point of this, is to just fill up the background. And then mask.append child mask rect. And I would have thought that would work. Oh, I have to set the fill to be white. Boom. All right, see that? We've got the inverse. And now that we have all of the pieces, let's put them together to create our LeWitt reproduction. What we need to do is have the rectangles that go in both directions present at the same time. Right? And so I can use VizHub to look back at what I've just created. So we've got these horizontal lines. Oh, and let me consult the direction. So the background should be vertical and the foreground should be horizontal. So in this one, we have the vertical lines. We should really invert this mask because, yeah, the foreground should be the vertical ones according to the actual piece. And then let's bring back the these lines that go in this direction. I'm just going to copy this block from here into here as another for loop that runs. N should be really only defined once. And check that out. That's kind of a cool intermediate state by itself. I think I'll fork from that. And at this point, what we need to do is create another mask that is the inverse of the mask that we already have. So I'm going to just take all this stuff that defines the mask and I'm going to paste it and rename this to be mask 2. And I'll call it circle mask 2. Not very creative. I'll just put 2 at the end of all these variables. All right, so now we have that mask 2 with the rect and the circle, we can invert these colors of the mask. So I'll change black to white, change white to black. And for these vertical rectangles, we can use the mask of the circle mask 2. So instead of circle mask, it should be circle mask -2. And boom, we have done it. There we have our Sol LeWitt reproduction. Awesome. Awesome. Yeah, this is so satisfying. I'd like to leave you all with an exercise to do between now and next week. Reproduce any Sol LeWitt piece, ideally using the JavaScript DOM manipulation that we've done today. And these are actually 3 different options for an exercise. I want it to be open-ended. So instead of reproducing a particular Sol LeWitt piece, you can create art. Just create generative algorithmic art in the spirit of Sol LeWitt. Very open-ended. You can be very creative, or add animation to what we created today. Like I was thinking maybe the textures could be rotating, or the circle could change size, or something like that. So these are your 3 options in terms of the exercise for this week. I have updated the forum index to have an episode 3 link. So when you submit your piece, please just submit it as a response to this thread, and I'll go over it. I'll review it next time. All right, questions, anyone?
I have a question.
Sure.
What is functional programming and objective programming?
Functional programming versus perhaps what you're thinking of is object-oriented programming.
Yeah.
That's a great question. It's very like abstract and philosophical in a sense. But I'll give you a brief take, my brief take on that. Functional programming generally makes heavy use of functions, and in particular passing functions to other functions. JavaScript is actually a functional language. It's been called Lisp in C's clothing, and I love that. I think that was, who said that? I don't remember his name. But yeah, JavaScript is Lisp, a famous functional language, in C's clothing. And C is a procedural language, and C++ and Java are object-oriented languages, meaning the central construct in those languages is a class, and then you can have instances of the class that are called objects. And so in the language Java, for example, an object is an instance of a class. It's fundamentally different than in JavaScript. An object in JavaScript is a set of key value pairs. That's often called a hash table in other languages. And then there's another language called Haskell on the extreme side of functional programming. In Haskell, there is no mutation. There is no such thing as let, and there's no such thing as reassigning a value to an object. So you have to create new objects all the time in Haskell. It's what's called a pure functional language. So if you want to really learn about functional programming, I would suggest to learn about Haskell. It's fantastic. But yeah, practically speaking, we are in the world of functional programming with JavaScript. Although it is a mix. I mean, in ES6 there is a class construct, and you can do object-oriented programming in JavaScript. I personally have sort of moved away from that. I don't use classes very much. I just use objects that have key value pairs that are expected to be a certain thing. And then there's the idea of TypeScript and type safety, which you don't have in vanilla JavaScript, but TypeScript is great if you want to be sure that there's no bugs regarding objects not having the things you expect them to. So that's my brief take on functional versus object-oriented programming. I see there are some. Yeah, go ahead.
What we see here in this one exercise we did just now is functional programming mostly, right?
I mean, is it functional programming? Is it object-oriented programming? It's almost like at too high of a level of genericness to even make a call. I mean, the DOM API is object-oriented in a sense that you're invoking these functions to create objects that are instances of a class, namely the class called DOM node. I believe it is. Yeah, so in this API that we're using, it's an interface, it's an abstract base class, and all of this terminology reeks of object-oriented programming. It's like, yeah, this is definitely object-oriented programming. They're having a base class, and in object-oriented programming, you have classes that inherit from other classes, and you have this whole hierarchy of stuff. So we are using an object-oriented API to the DOM. So in that sense, it is very much object-oriented. However, we're not, we didn't create any classes of our own. So in that sense, it's not object-oriented. And we're also not using any functions except for the methods on these instances of the classes. So when a function is positioned as a property of an object, it's often called a method. So these are methods on these objects, which is also from the object-oriented realm. Instances of classes have methods. That's just how object-oriented programming works. So if you were to, broadly say, is this code that we wrote today object-oriented or functional? It's more object-oriented, honestly. We're not using any functions, really. And even this way of doing iteration is very procedural. If we wanted to do it in a functional programming kind of a way, we would use some other constructs. And we'll do that later, by the way. I'm thinking next week we refactor this whole thing to use D3 and functional programming and abstract away duplicated logic with functions, just to see how things get really tight and concise when you do really embrace functional programming. And thanks, somebody in the YouTube chat said Lisp and C's clothing is from Douglas Crockford. Yeah. Douglas Crockford. He's got some really good stuff. Really good written pieces about JavaScript. Someone asked, could I do this using Visual Studio Code? Yes, of course. I mean, it's just a text file here. So in VizHub, by the way, you can export the thing and you get a zip file. You can extract this somewhere and then just open up index.html in Visual Studio Code, and everything will just work the same way that it's working here, except that you'll have to open up the file in a browser, and every time you make a change, you're going to have to save the file and then go and refresh the browser, unless you get deeper into the tooling of having something that automatically refreshes, like a Webpack development environment. Yeah, all this stuff I'm doing here is just purely HTML, standard HTML and JavaScript and SVG, and it's not in any way dependent on the fact that I'm in VizHub. VizHub is I'm just using as a teaching tool so that I can give you references to these code files. But yeah, you could totally do all this with Visual Studio Code. And as we get deeper into JavaScript, I think I'll get deeper into showing how to work outside of VizHub using different build tools. Yeah, great question. Oh, yeah, there's a discussion in the YouTube chat about classes in JavaScript is actually syntactic sugar for appending stuff to the prototype. It's very true. It's very true. But that's a whole other rabbit hole. There's like the when you create objects in JavaScript, you can actually create them to inherit from a prototype, which is it's just a whole can of worms that I just would rather not get into because we're not going to need those constructs. Another comment in the chat is you could have wrapped all this stuff in Vue.js. Yeah, it's true. It's true. I mean, this is a very crude way of doing DOM manipulation. But I wanted to explicitly use the DOM APIs just so you see what it is in its bare form. You could wrap all this stuff in D3, do it in React, do it in Angular, do it in Vue, anything. But the resulting DOM is going to be the same, and that's really what matters in terms of what you get, what you see on the screen. All right, I think I'll wrap for today. This has been a really good session, and yeah, I'm really super excited to see what you all come up with. Feel free to fork this or start from scratch. You know, be creative, add gradients or whatever, add animations. And all right, really looking forward to next week. Thanks everyone for joining. See you in a week. Bye.